there. Okay, so last time we defined a proposition as a declarative statement with either a truth, with either a true or a false statement. So it's necessary that we know what's the truth value of that declarative statement for us to be considered that as proposition. So now, again, as what I was saying, we will be working on connectives and compound propositions. So when we say a propositional connective, so this is an operation that combines two propositions to yield a new one whose truth value depends only on the truth value of the two original propositions. Okay, so and our concentration for now is to construct um, compound proposition using propositional connective, not necessarily identifying the truth value. But we will go to that as what I was saying in the next meeting. Okay. So, and these are the propositional connectives. Wait, how about yellow? I'll try it. So, we have this one as conjunction. Another, okay. Disjunction. And then this is conjunction, disjunction. This one is exclusive or. We also have the implication, this one, and this is the biconditional statement. So these are all the connectors or connectives. Okay, so and this will be defined by the truth tables. Um, in English, we are using conjunctions, right? Like we use the conjunction and we use the conjunction or and many more. And in math, we also have those conjunctions and we call them as connectives. Okay. Okay. So do not get overload with the truth table. As what I was telling you, we're going to work on each part of the truth table, but I'm just introducing to you the truth table with respect to the connectives or to the operators. Okay. For instance, we have statement P and statement Q. So we have two statements because our goal here is to combine the two propositions using connective. Okay. And for instance, um, if the first statement P has a truth value true or T, the truth value class is either true or false. Okay. And we just write T and this stands for true and F stands for false. And then another statement P, which is true also. And then another statement P, which is false and then false. And then statement Q with truth value true, false, true, false. Now, we are going to connect the two propositions P and Q using the different connectives and look what will happen to its truth value. Okay? So, for instance, if we're going to combine P and Q here by the connective conjunction and, so this is and, no? So this caret symbol is a notation for the connective end. Okay. And this is read, this one is read as P and Q. Okay. So this one is P and Q. Okay. Now, P and Q is true if both P and Q are true. So statement P is true here and statement Q is true. Now, if we combine the two using the connective end, P and Q has a truth value equal to true. Okay? Otherwise, everything will be false. Now, it's a requirement for P and Q that both statements P and Q must be true in order for P and Q to be true. Otherwise, it will be false, like the other three here. Why? Because statement Q here is false. Although statement P is true, we'll come up with P and Q equal to a false statement. Also, this time statement Q is true, but statement P is false. We'll also end up with P and Q false. And it follows also that P and Q is false if sorry, I lost my connection. I'll share my screen again. Okay, guys. Can you give me a thumbs up if you see my screen now? I'm sharing my screen. Bianca. Hi, everyone. Do you see what I'm sharing now?
Yes, Miss.
Okay. So I'll just proceed. So as what I was saying, in order for a compound proposition making use of the connective end to be true, both statements P and Q or both statements must be true. Otherwise, it will be considered false. Like on the case of the other three here. So we come up with, I'll make this darker. So we end up, gusto niya talaga ng yellow. Okay. So when we end up with false statement here, because on the second and third row, either of the statements is false. So we come up with a false statement here. Now, with the last row here, both are false. So definitely this is very false. Okay. So the condition for the connective end to be true, both statements must be true. Otherwise, that will be considered as false statement. Question, guys, with the connective end. Do you have question on that? So I'll just proceed. If you have question, you just unmute your mic or you send a chat. Okay. Now, another connective is the disjunction or. Okay, there's a chat here. Okay. Noted, noted. So P or Q. So this one is a notation for or, the connective or. Okay. So The first three here is true. And let's look at the rule under the connective or. So the first row, P and Q are true. So we come up with a true statement for P or Q. Now, second and third row, either of the statements PQ is true, but still considered as true. But the last row, both statements here are false. So we come up with a false P or Q. So can you tell me what's the rule for um, compound proposition using connective or? Who can tell me the rule for this, guys? Just unmute your mic and then identify yourself first. Okay, sige. Walang may gusto. So, if either of the statements is true or both statements are true, then P or Q is true. So that's why in here, both statements are true. So we come up with P or Q, true, to be true. And then with the second and the third row, either of the statements is true. So we come up with P or Q equal to a true statement. But with the last statements here, P and Q are both false, then it's considered false. So the requirement is just one statement to be true, then P or Q will be considered true. But if both statements are false, then P or Q will be a false statement. Okay, this one is exclusive or. Ayan, magsulat. Okay, exclusive or siya. Okay, let's analyze the result here and comparing the P and the Q here. So we have true here, and then it's false. We have both statements to be true, and then this is read as either P or Q. Okay, so either P or Q is false. With P and Q here, both true statements. In addition, class, we come up with either P or Q to be false also, since both statements here are false. On the other hand, look at the true statements of either P or Q here. Either of the statements P and Q here is true, then we come up with true either P or Q here. Who can explain what's the rule for either P or Q or exclusive or? Exclusive or from the word exclusive itself. So for example, the gender has to be gender ba? Okay, halimbawa, true or false test. You cannot answer true and false. It's either true or false only. Now, considering both statements to be true or both statements to be false is not an option for exclusive or. So there should be one true and one false in order for either P or Q to be considered true. Clear? Okay. Now, for implication statement, and this is read as if P, then Q. And this is also known as the if P, then, or if then statement. Okay? So this is again read as if P, comma, then Q. Okay? Now, everything is true except for the second row. Now take note that in if P then Q statement, the statement is divided into two parts: the premise, which is the first statement, and the conclusion, the second statement. Now everything is true except for this one. If the premise, I mean the first statement, for if P then statement, the premise or the first statement is true, it follows that the conclusion must be true. Now, if it's not true, then we'll come up with if P then Q a false statement. And everything is considered true. Also, if the premise is a false statement, whether whether the conclusion is true or false, then we can accept if P then Q to be a true statement. So you just have to remember that if P then Q will be a false statement if the premise is true, and then we come up with a false conclusion, then if P then Q will be a false statement. Now you don't need to memorize this, but you can easily understand the idea if you know the rule of each connective. So that's why I'm explaining the rule of each connective. Okay. Now, this biconditional PQ, this is read as P if and only if Q. Okay? So, take note that this is like the reverse of this one, exclusive or. So, if both statements are either true or false, then P if and only if Q will be a true statement. Yan. So ito opposite silang dalawa. So our next thing that we're going to do is we will set aside that truth table and then we will go back to that next meeting. For now, we're going to construct compound proposition using the connectives. So ganun muna yung gagawin natin for now. Okay. So if we let P and Q class be propositions, today is Friday and it is raining today respectively. So meaning this is, wait lang po. Okay. Ayaw yan ng yellow. One more. Mahaba naman ng pasensya natin eh. Okay. Yan. This is P. Okay. And this is Q. Statement Q, guys. Okay. So how do we construct P and Q? Okay. So we will just rewrite as is each proposition and we will combine them using the conjunction connective. Ayan, sige. Marami pa pala. There. So that's how we construct P and Q. Today is Friday and it is raining today. So that's how we construct P and Q from the given P and Q in the example. Okay. How about P or Q? So we made use of the connective or. Today is Friday or it is raining today. So we will not yet identify the truth value. In doing that, we will be working on statements we will be working on mathematical statements for us to distinguish its truth or to identify its truth value. Kasi with that one, we cannot tell, no? Otherwise, it will be added in the given that today is really Friday and it's a true statement. Parang ganon. No? Our main concern is how we construct compound proposition using connectives. Okay? Okay. So for if P then Q, if today is Friday, comma, then it is raining. So that's for if P then Q. And then next is if a P, if and only if Q. Today's Friday, comma, if and only if it is raining today. Okay? Okay, so let's work on the negation of the statement P. And this is read as negation of P. Now, this is the notation for negation, and this is read as not P. Okay? We make use of the negative word not. Okay? Um, Also, we are using this symbol for the negation. No? So this is also a symbol for negation. Okay. So if P is a proposition, the expression negation P is defined as a new proposition with the following truth table. Okay. So if statement P is true, then negation of P is false. Also, if statement P is false, negation of P is true. So that's the idea on the negation of statement. So guys, the expression negation of P is read as not P. So this symbol is called the negation connective. And this can be used as alternative symbol for negation. Okay, so how about the three terms tautology, contradiction, and contingency? There. Okay, so we're talking here of compound proposition, guys. Now, if a compound proposition, which is always true regardless of the truth values of the propositions that occur in it, it's called as a tautology. If it turned out to be always true, now we consider that as a tautology. On the other hand, we call that, otherwise we call that as contradiction. No, if it's always false naman. If neither a tautology nor a contradiction, then it's called as a contingency. We'll be working on examples on that. Now, I'd like to concentrate on equivalent statements. Okay. Now, let's consider P and negation of P and P or negation of P. Tingnan natin yan ha by constructing a truth table. So, if we have if we have two truth values for P, if P is true, of course, you will all agree that negation of P must be false, right? And then if P on the other hand is false, then its negation is true. Now, P or negation of P here must be a true statement. And so with this one. So, P or negation of P will always be a tautology. Do you agree? Because what's the rule for the connective or? Either should be true in order for that to be considered true. Since we are combining the negation of a statement and itself, definitely we will come up with one either of the two statements to be true. So, if that's the case, then P or negation of P will always be a tautology, will always be a true statement. Okay? On the other hand, class, with P and negation of P, it will always be a contradiction. Do you agree? Kasi ang rule natin for and, connective and, both statements must be true. And if we are combining um, a statement and its negation, of course, one will be true, the other one will be false. So, P and negation of P will always be a contradiction. Okay. Now, as regards to tautology, the propositions P and Q class are logically equivalent if P equivalent to Q is a tautology. Okay? So, excuse me. So, let's work on example for logical equivalence. Okay. Medyo overloading lang. Anyway, I'll be sending the lecture video for you to review, no? So show that the following are logically equivalent. So we have negation of quantity P or Q and negation of P and negation of Q. So this is how, so this one, which is this, and this one, which is this. So if they have the same truth value, then they are logically equivalent. Okay? So I will explain why we come up with that table. So we can say that the two are logically equivalent if they have the same truth value. So how did we come up with this one and this one also? So we have statements P and Q. If P is true, Q is true. So we have to work on P or Q first. So P or Q here is true. This is true also, this is true, and this is false. So you all agree that these are all correct. Now, how did we come up with negation of quantity P or Q? We will just get the negation of all of this. So if this is true, its negation must be false. Yan, black tayo. Okay. So, false siya. If this is true, false. True, false, false, true. So, that's how we get this one. Okay? So, since we are going to work on the truth value of negation of P and negation of Q, we have to work on negation of P and negation of Q. So, if P is true, its negation is false. True, false. False, true. False, true. Likewise for Q, true, false, false, true, true, false, false, true. Now, we will combine the two statements using the connective end. So, negation of P and negation of Q, so both are false, so this must be false. Either is true, and then it has to be false. So, the condition for the connective end to be true, both must be true. And this is the only true. And comparing the two, so the two here, yan, they're equal. So the two statements here are logically equivalent. I think it's the end of, wait.